Hi everyone. Today we are going to discuss about the module 3 deflection of the beams. Okay. So when we are going to apply the load, maybe as a uniform distributed load or point load or uniform varying load, what will bending beam going to start the deflecting? That we need to able to find out the deflection and the slope of the given loading systems. So various methods are available to find out the slope and deflection. That method only we are going to discuss about the module 3. Okay. So we are going to discuss about the double integration method, McCallis method, moment area method, and conjugate beam method. Using this method, we can able to find out the slope and deflection of the various loading systems. So what is main objective? Main objective of this module is to understand the concept of the beam, deflection, and the slope under the varying loading condition. So for a given beam loading condition, maybe varying of the unit point load is available, then uniform distribute load and uniform varying load. Based on the loading condition, beam may be varying or deflection in different formation. So using a different method, we can able to find out the slope and deflection of the given beam. Then learner to study the double integration method and the mechanics method to analyze the deflection of the analysis. To learner to explain to area moment area of the method, and it's based on the application that given the problems. And we are going to introduce the conjugate beam method that determine the slope and deflection methods. So this is a 4 module objective of the module 3. This each and every method we are going to discuss about it in this module. So what is in the basic concept of deflection? When you given beam to applying for any point load or uniform distribute load, uniform weight load, the beam started to deflection. The main definition of the deflection being from the axis of the beam before bending, after bending, having going to deflect it. We can call it as a Y or delta B, whatever may be. That distance we can call for the deflection of the beam. What is the real definition? Any point of the axis of the beam, if you take the A and B, total of the beam, we started to applying load. What will happen? The beam started to bending. So position before and after loading, we can able to measure that the distance we can call the deflection of the beam. So maybe it's a beam or slab due to the effect of the loads acting upon this bend with the initial position to the before going to apply. That distance we can able to measure, that is called for a deflection of the beam. Okay. What is in the slope? Yes, applying the load also, any section deflected beam, the angle may be formation with A and B, the angle formation. That angle we can call it as a theta. That theta called for a slope of the given beam. So any angle in the radians, the tangent at the section make with the original axis of the beam, that is called for slope beam. So how we define the for a slope of the beam? The angle between the initial position to the deflected position. What is the initial position? You're not applying load, that is the initial position. After that, some deflection will be possible to make. No? That is deflection. That is what called the slope of the beam. So based on this, you can able to find out the deflection of the beam and the slope of the beam. When you are saying the deflection of beam, we can able to mention as a Y, that is a deflection beam. If you deflected for the integrating, what we will get for dy by dx, that we can call for the slope. Again, if you deflect one more time to differentiation, you will get for bending moment, that is the EI into d square y by dx square. So shear force, once again we need to integrate EI equal to dq by dx cube. Again, if you integrate one more time, the rate of loading will get EI equal to d over 4y by dx for 4. This is a general formation of the equation. So whatever may be the loading condition, unit or point load or uniform distribution load, when you started to find out the deflection y, we need to integrate each and every step. We'll get for slope, bending moment, shear force, and various rate of loading also we can able to. So using this relation, we can able to find out the slope and deflection using the given type of the methods. One is a double integration method, moment area method, mechanics method, conjugated beam method, and energy method. So these are the methods are available to find out the slope and the deflection of the given beam. Now in this module 3, we are going to discuss about the first four method, double integration method, moment area method, mechanics and conjugated method for a given loading system. Find out the slope and deflection methods. Okay. So what is a double integration? Is a basic analytical method. We need to frame the bending moment equation. from the bending moment action given loading system, we can able to find the slope and deflections. Okay. So what is a generally governing equation? D square y by dx square equal to m divided by bending moment divided by Young's modulus into moment of inertia. When you started to mx, no, the bending moment, we need to integrate it twice. Okay. First integration will get for slope, and second integration will get for a deflection. Okay. So for this, no, we having different type of the boundary condition. Using this boundary constant integration boundary condition, we can able to find the slope and deflections. So what is the main advantages when you started to using the double integration? We'll get for very accurate, because it's a single point load. When you started to derive and getting the equation, we can able to substitute the value in the value. We'll get for slope and deflection very easily. This is a very accurate method. So applicable for all the basic beam problems. Okay, when you say simply supported for single point loading or a fixed beam for a single point loading, it's very good. We'll get the more accurate application for the slope and deflection method. Okay, so what is the limitation, disadvantage of when you started to using double integration method? It will take for lengthy calculations and difficult when many point loads are present. If you take the simply supported beam, if you are applying the more point loads A, B, C like that, you're having a different point loads, or we having continuous beam, we having a different point of the load. So continuous point load and uniform distance load, various loading system is available. It's very difficult to find it the slope and deflection. So in this constraint, if you're having a more load, more support, either we need to go for a other method to find out the slope and deflection methods. So then where we are going to apply use for the double integration method, simply supported single point loading system, cantilever beam fixed with a simple bending, so simple loading condition, we can able to apply for the double integration methods. Okay, you see, all the loading system is a very simple. Okay, for cantilever beam, it's like only one point load. Cantilever with a UDL, and cantilever is a simple movement will be calculating, and simple supported with a point load with the UDL. So simple loading configuration system, we can able to find out the slope and deflection for given loading. So this will be second column is source about the elastic curve. For that means y max, okay, for different loading condition, how will bending will happen, and what is the maximum deflection when you point load, a uniform distance load, or a couple or simple supported cantilever or whatever may be the condition, what is the maximum deflection will be occur. Okay, then slope at the end A or B, what is the slope will be occur when you point load, uniform distance or different supporting condition, and what is the general governing equations to find out the slope deflection or elastic curve, that is also shown in the tabulation form. So it will be evidentially proved that single point of the loading or simple configuration of loading and supporting system, we can able to apply the double integration method to find out the slope and deflection of the given beams. Okay, so next method we can see for the moment area method. So what do you need to do? We need to find out the moment area we need to calculate based on the bending moment calculation. Okay, so this method related to the area of the bending moment diagram to the to slope and deflection is based on the two theorem. So a moment area method is applicable for the two theorem, and theorem one says that change in the slope between the any 2 points. We suppose you will take for A and B 2 points, to change the slope and between the 2 points equal to area of the bending moment diagram between those 3 points divided by EI, we will get for slope of the given loading systems. So deflection had to be moment area bending moment diagram about the point divided by EI. If you do, we will get the deflection at the beams. Where we are using for a moment area method, very fast method we can able to use. Once we know the bending moment diagram, from that we can able to find out the slope and deflection method. Easy when bending moments is simple. That means what is that? If you have again simple loading condition, supporting condition, we can able to draw the bending moment diagram. From that bending moment diagram, we can able to find out the area. From that we can able to find out the slope and deflection methods. What is the limitation of this method? difficult to complicate the bending moment diagram. Because suppose more loading condition will be there, continuous loading or point loading, different uniform varying load. Their bending moment also be quite difficult. Difficult. Those type of thing very difficult to find out the moment area, and then find out the slope and deflection method. So it is not suitable when load varies irregularly. There is uniform varying loads on one condition, the same beam, UDL in one and point loading in the other one. So this type of typical loading condition very difficult to find out. So it's very useful for this type of the moment area method. Beams with a simple bending moment diagram and conceptually understanding of the deflection if you know already, then we can able to use for a moment area method to find out the slope and deflection. Next method is important method, so Michaelis methods. It is an extension of the double integration method. So here we are going to use for a Michaelis bracket method. Okay, what is a bracket? X minus a whole power 1, x minus a whole power 3, like that. It will be the continuous. Okay, to handle the points load and discontinuous, we can use for the Michaelis method. A single bending moment equation written the entire beam. If you entire beam or simply support or continuous entire beam, having a different load condition will be there. Each and every load condition you can able to form the single equations. Okay, so this is the main advantage of the Michaelis method when compared to the other methods. Where we can able to form the simple one equation. From that we can able to find out the slope and deflection. So what we need to in this equation, we need to integrate the twice. Okay, to find the slope and deflection. Okay, so where we can able to use this type of the method in the beam load having a multiple point loads. Okay, if you take the point support A and B, in this between the A and B, maybe chances of different point load will be applicable. Okay, so unevenly spaced of the support condition. So based on that, we can able to use for Michaelis method. So writing the separate equation is important. Each segment is very difficult. Using the Michaelis method, we can able to form the single equation that is called Michaelis bracket. X minus A equations. A single bending moment equation is written for the entire beam different loading condition. The terms become active when the x equal to A. Okay, that boundary condition is applicable for Michaelis methods. Now, how to find out the Michaelis method of slope and deflection? Write one combined bending moment equation along the all loading system. We need to integrate the twice, then apply the boundary condition. Based on the boundary condition, what is x equal to 0, x equal to L, x equal to what is the distance, everything we need to implement in the boundary condition. Then we need to find out the slope and deflection of the given beam. Main advantage of this Michaelis method, handle multiple loads will be easily. The single point between A and B, having a multiple loads, we can able to find out them not easy. Then less calculation than the double integration method. So what is the limitation? Slightly difficult to understand initially. Yes, of course, no. More having more values, it is very difficult to understand. As well as to understand the to frame the single equation, and then bracket mechanism, bracket method to apply the boundary condition initially is quite difficult. Once if you understand it clearly, it's very easy to find out the slope and deflection using the Michaelis method. So where we use this type of the method, beam with many point loads. Okay, several point loads and UDL we can able to use this. And university numerical problems we can use for only for majority of the question will come for this mechanism problems only. Okay. Next is the advanced method is a conjugate method. It's a graphical analytical method when compared to others. So this is also we are going to use for theorems. The conjugate will be formed by changing the support condition. Okay. Real beam on support condition will be when they are making as a conjugate beam, the support condition will going to change. So loading and the conjugate will be M by is a real beam. Okay. Then we can able to find out the shear force conjugate beam is a slope and bending moment is the conjugate beam is a deflection. This is interchanging it will happen for the conjugate beam. It's a very powerful method. It's a clear physical meaning. We can able to when you're seeing the picture when bending moment diagram, we can able to clear picture support and bending moment will be changing the conjugate beam. So need for strong understanding shear force diagram and bending moment. So we need to understand the various loading system, how to calculate the shear force and the bending moment, how we need to draw the SFD and BMD diagram. Then only we can able to understand cope up with it to find out the slope and deflection method using the conjugated beam. Okay, so useful for the beams, already we next module we are going to see what is the determinate and indeterminate. So this conjugate beam we can use them for the determinate beam, and no advanced conception question we can able to arrive for this conjugated beams. So dear learners, this is a four method we studied little bit introduction about the different type of the deflection methods. Now what do you understand as a learner, you can able to explain the beam deflection behavior due to the different loads and its supporting conditions. Okay, so based on the various supporting conditions, a loading condition, you can able to explain the how the deflection will happen in the given beam system. So as a learner, you can able to apply the double integration method and mechanism method to calculate the slope and deflection of the beams. Learner, you can able to use the moment area method to determine the slope and deflections efficiently when you understand the fundamental concept. To analyze the beams and problem, you see the conjugate beam methods. Okay, so these are the module outcome. You can clearly understand that. Hope this module 3 you understand the basic fundamental concept theory, where each and every, what is the definition of each and every method, what is the advantage of method, what is the limitation, where which type of beam we can able to use for different types of vehicle to understand. When next module we are going to discuss a few problems or different type of the method, then we can learners we can able to understand very easily which type of the beam, which boundary condition, which supporting condition, which loading condition we can able to use to find out the slope and deflection methods. This is a textbook reference book. We can able to see all the four methods will be available. It's given the classical example to solve the numerical problems, and example problems also given. Strength of material be RK Urban Solves textbook. So thank you learners. Learning for module 3. Very soon we are going to see for module 4 indeterminate beams. So thank you all.